So techniques for solving equations like this. We can use your calculator. That's us.
Shoot, is that an option?
Yeah, on your phone or computer.
Great.
Which one?
My computer.
Okay, so just why don't you just hang out here and show me that when you're ready. So I'm tempted to do something like divide both sides by the cosine of x, but the problem with that is I could be sometimes dividing by 0. But we don't want to do that. So the safest thing to do is use addition and subtraction at first. So I'm going to subtract the 6 cosine of x to the left. Now, at first glance, what I have really is 10 sine of x, cosine of x, minus 6 cosine of x. And on the other side, I'm going to have a 0. I can't do any simplification of this right away. For example, my brain's dying to do something right there, but there's nothing I can do at the moment. These aren't like terms. Kind of another way to think about this is a lot like having the equation 10y times x equals 6x. And I could write it like that until I get x and y alone. And I would subtract 6x from each side here, but there's nothing magic happens there except 10yx minus 6x, right? They're not like terms and stuff. So there's a lot of times is if there's more sines and cosines than this, I'm going to rewrite it with x's and y's like that because it's just easier to do. I'm not going to do that here though, sorry. But it's like that. We're going to use the 0 product rule. So when you have 0 on one side, if you can write the other side of the product as a product, you can break it into easier pieces. Does this factor in any way? Any common terms on each side of the subtraction?
2.
A 2 and?
X.
Not an x, it's stuck inside the cosine and sine. So I can factor a 2 from the 10 and the 6, but I can also factor a cosine out from each side. So I'm going to factor out 2 cosine of x. And factoring is like dividing. Whatever's left is as if you divided the cosine of x away and the 2. So 2 goes into 10 5 times. The sine is still hanging out, but I divided this cosine outside. And then I'm going to have a minus 3, and I took the cosine, so there's just a 3. So once I can rewrite this as a product, I can now split it into 2 different problems. One of the problems is twice the cosine of x equals 0. Ooh, I like that one. And the other one is 5 sine of x minus 3 equals 0. And we've done ones like that before. All right, so let's solve the easier one first. So on the left side, I would divide by 2, which is nice because 0 divided by 2 is still 0. And then let's think about this unit circle. When is the cosine 0? Let's see, cosine is x value on the unit circle, the x value is 0 up here and down there. So I want from, let's see, 0 to 2 pi, so that means measure the angle this way. Well, that one of these solutions is pi over 2. And the other one I have to get down here in a positive rotation, which would be what? 1, 2, 3 pi over 2. So I believe from this branch, x could equal pi over 2 or 3 pi over 2. On the other multiple of this, we're going to have to add the 3 over. 5 sine of x equals 3. and then divide by the 5. So sine of x is 3/5. Let's see, 3/5 is not a special number related to my special angles. The unit circle, signs of y value. So that line right there would be y equals 3/5. And 0 to 2 pi, I want the first two positive solutions. So I want this angle here. And that angle there. How do I find the red angle? Call that one theta here. Well, that's given here, the 3/5. I have that. I want to know what angle goes with it. So this says the sine, what the arc sine, yeah. So this says the sine of some angle is 3/5. So the arc sine, remember, is active on the right side of the unit circle. So then that red angle theta is what the arc sine is going to tell me. So if I enter into the calculator, what's the arc sine of 3/5, it's going to say that angle right there. How about the green angle? Call that one alpha. Well, it's got the same reference angle. So this angle right there is the arc sine of 3/5. I want that angle right there. It's related to pi. So what am I going to do with pi and what I have to get the green angle?
You add pi. Or
If I, yeah, add or subtract, right? So if I added it, the arc sine over here is a positive number. So if I added it to pi, it would put me over here. So I want to take it away to get back there. So my green angle alpha should be pi minus the arc sine. In that case, I want to take the reference angle away because the reference angle is positive. Will there be any other solutions? Let's just go back to each one. Starting with twice the cosine equals 0, that leads to this picture here, and there are only two angles in one revolution that work there. Similarly over here, we worked this down to the sine of some angle is 3/5, and according to the unit circle, there's only two possible angles that can be, so it looks like we found all four solutions. Next, I would check on a Desmos. How would I check it on Desmos? When I check on a calculator, I always go back to the original version. So I would do this as f of x and this as g of x, and then test out the numbers I found. Do they really meet there? Right, which shouldn't be too hard. Let's do that. Clear this one out. All right, so I'm going to do f of x was the left side, so that was equal to 10 times the sine of x cosine of x, and then the g of x is just 6 cosine of x. And I think I've identified these solutions here. The next one, oh, I missed one down here. In order, 1, 2, 3, 4. Okay, that should be done. So double check my notes. I did find pi over 2 and 3 pi over 2, which Desmos recognized. That's good. So checking the other ones. All right, so let's see. It was related to the arc cosine, right? No, arc sine, thank you. Arc sine of 3/5. 0.64, that I think is gonna be this one. 6435, that looks good. And the other one was pi minus that, so pi minus 2,4. And I think that was down here. 249,809. Cool, we got it.
How'd you know which points they were gonna be?
Because I was asked to find solutions between 0 and 2 pi. So I was looking for intersections as x went from 0 to 6-ish.
Hmm.
So starting over here, I noticed that was the first intersection, and then following the blue curve, there's the second one,
They're going.
third one, and then there's the fourth one right there.
See.
And then after, the next intersection is after 2 pi is a little bigger than 6. That happens after 2 pi. So that wasn't part of the ones we found. How do I, suppose it did say find more, how do I identify that number up there?
2 pi plus.
2 pi plus the first one. Yeah, they're just gonna keep happening in that same order again. So we can add 2 pi to any one of those and keep going. At least because the cosine of x has a period of pi. When you multiply the sine and the cosine together, it's got a different period. What is this period? It looks like this period is pi. Cool. We'll prove that later. All right, let me see what's next. Stop recording. Another one. How are we doing on time? We're doing great.